Hello, Algebra 1. Today we're looking at differences of squares. And before we get into the video, just wanted to quickly note that this video goes with the week that starts March 30th. This isn't due until April 6th. So if you get a notification, oh, Miss P put up a video, you don't have to do it right now. If you're working ahead, that's fine. This isn't due until April 6th. So if you're watching this the day I put it up, you don't have to get working on it right away. If you want to, that's fine, but you don't have to. This is due April 6th. If you're watching this on April 5th, maybe get to work on it. Okay, so differences of squares. So think back to when we were foiling things. When we were foiling things, we said there were a few shortcuts that we could use, and one of them was if we have two things that are the same except for one is positive and one's negative. So if I have an x plus 7 and an x minus 7, when we FOIL this out, what happens is we get an x squared minus this 7x plus this 7x minus this 49, and your two middle terms end up canceling, and we just get this. Now we're going to go in reverse. So anytime you see something like this, that's a big clue that we're going to end up with something when we factor it where we have a positive and a negative of the same thing. So if instead of like an x squared plus something x plus something else, if we just got an x squared minus something, it's probably going to end up looking like this. So for example, if we have an x squared minus 81, we're looking for a positive and a negative of the same number that are going to give us 81. So really what we're looking for here is we're looking for the square root of 81. Because when we're taking 7 times 7 here, we're really just squaring that 7. So 49 is 7 squared, which means 7, if we were looking for that, is the square root of 49. So the square root of 81, well, that's just 9. And if that's what you know off the top of your head, cool. If you get to one that you're not sure of the square root off the top of your head, just go ahead and plug that into your calculator and look for the square root button. So as long as we just have an x squared and then minus something else, and importantly, this only works if that's a minus. This doesn't work if that's a plus, and that doesn't work if that's not an x squared. So for example, if I wanted to factor this x plus 9 and go, oh, well, that's x plus 3 and x minus 3, isn't it? No. Because that is what we would get if we had an x squared minus 9, not this, so don't do that. So really part of this is just knowing when to stop, and we're stopping once we've got x's. So once we've got x's, we really can't factor that anymore, because there's nothing times itself that's going to give you x, unless you get into like the square root of x. So I mean, you could do that, technically you could factor that into the square root of x plus and minus 3, but don't do that. Don't do that. We're looking for nice whole x's. Okay. Or m's in this case. So if we get an m instead, different variable, same idea. So we're just looking for the square root of that 64. And if you happen to know off the top of your head that the square root of 64 is 8, cool. If not, go ahead and plug that into your calculator. And again, we want a positive and a negative of that 8, and no, it doesn't matter what order they're in. I tend to write the positive one first and then the negative one, but order doesn't matter there, so you could just easily go, hey, I want my positive here and my negative here. The important thing is that we have one of each. So it's either a positive and then a negative, or a negative and then a positive, one of each. Okay, now, what if it's not just an x squared? What if we've got a 5 in front of that x squared? And you may notice, if we're looking for a square root of 80, 80 doesn't have a nice square root. Neither does 5. So if you've got stuff that's not going to give you nice square roots right away, the first thing we're going to do is we're going to factor out our biggest number that goes into both of them. So we're looking for the biggest thing that goes into both 5 and 80. So basically just reverse distributive propertying this. So the biggest thing that goes into 5 and 80 is really just 5. And in general, a nice place to start is just to see, does this number go into that number? Because if it does, that's going to be your biggest thing. There's not going to be anything bigger than 5 that goes into both of these, because nothing bigger than 5 goes into 5. So if that's a number that goes in here, that's a nice thing to check first. That way you don't waste your time going through all the other things. Now, 5 was nice. It only has those two factors in the first place. Okay, so if we take a 5 out of this, if we divide a 5 out of our 5x squared, that's just an x squared. And watch out for, if we're doing this, we're dividing. So this is 80 divided by 5, not minus 5. And 80 divided by 5 gives you 16. Now, importantly, don't stop there, because now we still want to do this because we still got this x squared. So if you had an x squared and then minus something, that's when we want to go back to this and say, okay, well, I want the square root of that 16. And the square root of 16 is 4. And again, if that's one you know off the top of your head, yay. If not, go ahead and plug that into your calculator. Square root of 16 is 4. So again, plus and minus of that, and that 5 is just hanging out here. So that just needs to not disappear on us. So there's our factored form of that. Yay. Let's try another one. So we got something with an x cubed this time. So same sort of thing. None of these things are going to give us nice square roots as they are. So we're looking for the biggest thing that we can take out of both our 10x cubed and our 40x. Just an x. So biggest thing that goes into 10 and 40, and there's my cat. Say hello to Mirage. Okay, Mirage, you gotta move. You gotta move, kitty. There you go. Okay. I could edit that out, but it's probably more entertaining to just leave it in. Okay, so we've got a 10x cubed minus that 40x. So 10 and 40, the biggest thing that goes into both of those is just 10. And again, this is a nice thing to check first. So you could go through and go, okay, well, 1, 2, 5 goes into them, but 10 is bigger. So if this goes into that, that's going to be your biggest thing. So we got a 10. And then along with that, we've got an x cubed here and an x there. So we're going to pull out an x as well. And Mirage, you really need to get off that table. Sorry about that. Can't move. Okay, don't make me lock the door on you. Okay, so we're going to pull out that 10x. When we do that, that 10 is gone. If we divide an x out of that x cubed, now we've got an x squared. And if we divide a 10x out of that 40, 40 divided by 10 is 4. We took that x out, and that minus just hops on down. Cool. Now, again, we're looking for the square root of 4. And if you happen to know off the top of your head, and that's 2, that's probably one you should know off the top of your head. So the square root of 4 is 2, so plus 2 and a minus 2 there. And then again, that 10x is just hanging out here. So that just needs to not go anywhere. Alright, one more of those. So we got something like this. Can't mess up that 8 there. There we go. Okay, so again, biggest thing to look for is, in general, does this go into this? And if they're the same thing, boom, that's our biggest thing. So we're going to pull out an 8. And then they both have a y, so we're going to pull out a y. Okay, that 8's gone. Now, if you want to throw a 1 in front of there, that's fine. If you want to say 1y, you can. You don't have to. I'm just going to call that a y. Y squared. This one, we do need to put that 1 there, because otherwise there's nothing there. So if we take an 8y divided by an 8y, those cancel out, but when they cancel out, that's really 1. We just don't usually put it there, but really there's a 1 there and a 1 there that we're just not writing in, because if there's something else there, we don't need it there. But if it's going to be the only thing left, then it needs to go there. Like if we had 4 over 4, that would be 1. And since that's the only thing that's there, it needs to be there. Most of the time, it's just like a placeholder, like, okay, we can put that there or not. This time, it needs to go there, because otherwise, there's nothing there. And we don't want to put nothing there, because nothing would just be 0, and 8y times 0 does not give you 8y. Okay, and then we're looking for the square root of, hey, 1. That's another one you should know off the top of your head. You should know that the square root of 1 is 1. If you want to double check it by plugging it into your calculator, you can. That's one you should probably know. So we got a plus and a minus of that 1. And again, that 8y hanging out here. Okay. Now we're going to make it a little bit trickier, but not too bad. Okay, can't set on that, right? What if we got an x to the fourth instead? Now, you might notice that this time there's nothing we can take out of both of those, because there's nothing that goes into both 1 and 16 aside from 1, which would just give us the same thing back. So, we're going to go right to factoring. But instead of putting an x and an x here, I want to know if I FOIL this, what times itself would give me an x to the fourth? So we're looking for something that we could take times itself and get this. So instead of an x, we're going to have an x squared. Because if we take an x squared times an x squared, remember, if we're multiplying things that have exponents, we're adding the exponents. So 2 plus 2 would give us that 4. And then again, we're looking for the square root of 16, which is 4. You may notice a lot of these, the same numbers are going to pop up again and again. That's because there are only so many things that have nice square roots without getting ridiculously large. So 16, 25, 36, those ones are going to pop up a lot just because they're the things that give us nice square roots. So we're going to plus and a minus on that one. But watch out for, we're not done. Because we can still go a little bit further. Not with this one, but with that one. Because remember, this thing only works if we have a minus there. So this one, since we've still got an x squared, we can take it and turn it into an x and an x. And the square root of 4 is 2. And that's a plus 2 and a minus 2. And really the big thing there is just realizing that that's a thing you need to do. So we got one more step after we're here. And then that x squared plus 4 is just hanging out here because we can't do that with that one. Because that one's a plus. So this only works because that's a minus. So this whole thing is what we want. Let's do one more of those. Alright. This is where you're probably going to want to use your calculator. Because we're looking for the biggest thing we can take out of both of these. And again, the first thing you probably want to check is that 5. And 0 at the end is a nice clue that 5 does go into there. If you don't know off the top of your head, though, how many times 5 goes into 320, you're probably going to want to plug that into your calculator. If you happen to know that's 64, cool. Okay, so we're going to take that 5 out first, because none of these things are going to give us nice square roots without doing that. So we've got an x to the fourth left, and then that's 64, because 320 divided by that 5 gives you 64. Okay, now it's the same thing we were just doing. So now I'm going to take that 64, and we want the square root of that. Square root of 64 is 8. And that's an x squared and an x squared, because that's going to give us our x to the fourth. Square root of 64 is 8, and a plus and a minus. And this time, you don't want to do that thing we did on the last one where we had an x plus and a minus something, because 8's not a thing that's going to give you a nice square root. So if you have something where you're going to get a nice square root, you want to do that. If you don't want to do that. Now, technically, you could do this. It wouldn't be wrong if you did this. You can, you don't have to. So the only time you have to go through and do this is if that's going to give you a nice square root. If it's not going to give you something nice, I mean, you could, but the idea of this is to make it simpler. So you could make an argument for this is simpler or this is simpler. I'm 90% sure the back of your book just stops here. I would just stop here because there's really nothing you can do with the square root of 8. But maybe you want to do that, you could. Okay, so that's where I would stop. And again, really the big thing with these is just like, where do you stop? And we definitely don't want to do it with this one because that has a plus, not a minus. Alright, and just a heads up that if you're looking at the numbers for the homework below, I put 17 and 18 at the end. because they're the ones where you're going to have to go through and do this twice. So I just wanted those to stick out at you. Most of them are the things we're doing at the start where you just pull out the first thing and then you want the square root. 17 and 18 are the ones where you're going to have that extra step at the end where you do it again. So I just want those to stick out. So if you're looking at the numbers going, why are those at the end? The numbers usually go up in order. That's why. So, I mean, I don't care if you do those two last, I just wanted those two to stick out. So just make sure that you watch out for those are the ones where you have that extra step, where you have an x to the fourth that's turning into an x squared, and then an x squared that's turning into an x and an x. Alright, on that note, go ahead and check out the homework in the description below, and I'll see you in the next video.